All right, look at packet page 9 in your science skills packet. It's white. This is what it looks like. So it's independent and dependent variables practice. On your blue sheet, you need to be able to identify independent and dependent variables. You also need to be able to write your own hypothesis. So it says, fill in the vocabulary term on the left for each description on the right. So all those bullets are blocked together. So each one of those things is going to correspond to the same word that we're looking for. So this is the vocabulary term that says, I can make changes to this variable. This is the vocabulary word that says, this is the only thing that can be changed in an experiment. I wonder what it is. This is the vocabulary word that describes the cause and effect. It's the actual cause. They tell you what it is right here. The abbreviation for this is IV. And I can ask myself, what am I changing? And in your class, your silly teacher always says, I've got the power! Like Bruce Almighty, I've got the power. What do you have the power to change in an experiment? The answer to this is the independent variable. Lots is the vocabulary word you need to know and be able to identify. I will collect data from this variable. It is like the effect in cause and effect. Data effect. Initials for this one is DV. What am I measuring? What am I looking for? What am I observing? What is the data I am collecting? D. It's going to be the dependent responding variable. An educated guess or prediction. I hate educated guess. But we have to predict. So when you predict, you are going to guess what's going to happen. It should be written with an if. If the blank, then the blank will do what? Equals. So it's an if-then statement. So this is your prediction. This is your inference. This is what you think is going to happen in the experiment. This is how you write your hypothesis. All right, let's practice now. We know independent variable is the one that I have the power of. I'm changing it. The dependent variable is what's going to happen. It's the effect. And the hypothesis should be written as if then. All right, will an egg float higher in water with more salt? So what are we testing? What do we want to know? We want to add more salt and see if it will float higher. So let's write the hypothesis first. What are we doing? Adding more salt. So if I can turn back now. Oh wait, I have to sing it. I have to do the hypothesis. Hypothesis. If I add. What am I adding? More salt. Then what's going to happen? It's THEN, then. Then the egg will do what? Float higher. The data you're going to collect is how high it floats. You're changing the amount of salt. Will float higher. I know, I'm sorry. I'm not saying it because it's a lot of work. Okay, if I add more salt. Salt is what I'm changing. What am I measuring? How high it will float. Hello. How high it will float. So that means my independent variable, my IV, is the amount of salt. That's what I have the power to change. My dependent variable is how high it's going to float. You're going to measure how high it will float. The egg. How high the egg will float. And the end day, good? We understand what's going on? Alright, let's go to the next one. If you don't understand still, practice. Try this one on your own and then go over the video with me. Pause it. Try it on your own. Ivan and Braxton want to know if stretching a rubber band at different lengths affects how far the rubber band will fly. They use centimeters for all measurements. Let's do the hypothesis first, so then we can write out the independent and dependent variable. So my hypothesis, what is my prediction? What words am I starting with? If. I. What are we going to do? Well, you're going to stretch your rubber band. If I stretch the rubber band, Then, what do we want it to do? We want to see how far it's going to fly. Farther. You have to be definitive. You have to tell me what you think is going to happen. You have to tell me exactly what you're going to do. My independent variable is how much I stretch the rubber band, because I'm going to change it. I stretch it a little bit more, and keep doing the experiment. And then I have to figure out how far it goes. My independent variable is how far it goes. How far it flies. What do we think? Are we getting the hang of it? Alright, well, here's another one. Will a paper airplane with longer wings fly farther than shorter wings? What do you think? Predict. If I fly a plane with what? Longer wings. I have no idea. I never even thought about this. Then, what do we want to happen? It will fly farther. The independent variable is the thing in the experiment I'm changing. I'm going to change the size of the wings. The dependent variable is the data I'm going to collect. I have to measure and observe how far it flies. How are we doing, folks? Let's do this one, and then we're done. I'm not going to do the last one. Will a plant grow higher with more light? Hypothesis. If. What are you going to do? I expose a plant with more light. Then it will grow. Height. What do I have the power to change? What am I testing? The amount of light I give the plant. So some plants will have 1 hour of light. Some will have 2 hours of light. Some will have 3 hours of light. Some plants will have 4 hours of light. All the same type of plant. But then I have to measure how high it grows. The more it grows, the better it will succeed. The healthier it will be. Maybe, who knows. Anyway, your independent variable is always in the beginning. Look, I underline it. The dependent variable is always after the then. It's the cause and the effect. If you still are not sure how to do this, come see me. You need to master hypotheses, independent and dependent variables.